Write down topic Earth gravitational fields. Right. We discussed what is the gravitational fields of the mass when we are in r distance from the mass. What is the gravitational field intensity G equals Gm over r square that we have derived, and we are discussing today the Earth gravitational field. So write down, write down. According to the mass of the Earth, according to the mass of the Earth, a specific specific gravitational field, gravitational fields has been created, has been created around it, around it. Right. This is the gravitational field around the Earth. Right. Right. Take down this one. So we have to take the gravitation, take the gravitation at the, we can take some stages, right? So considering take down this one. So considering the gravitational field, we have to consider, we have to consider inside the Earth, inside the Earth, what is the gravitational fields? I take as the radius is r in Earth. First of all, I have to take what is the gravitational field inside the Earth, inside the Earth. The radius is r. Then I have to take the what is the gravitation field on the Earth. Then I have to take the what is the gravitational field around the Earth. So we will talk about these things separately. I take as this is A situation, B situation, and C situation. So okay, write down. Let consider, let consider the surfaces simple A are smaller than to capital R. Symbol B, R equals to capital R. Symbol C, greater than to capital R. Situation. We are discussing these situations. We are discussing these situations. Okay. Right. Write down, note down this one, this one also. Make a tanda. So we have to consider these 3 points, right? What is the gravitational field in this tree? Okay. So in the previous one, we know what is the gravitational field from the r distance from the capital MS, right? If you didn't memorize, note down gravitational field intensity of 4 point. What is that one? GA equals to GM over R square. Right? In this case, we are taking as M, which covered into the this radius of the sphere. Right? Okay. In write this one and take M should be taken as the mass inside a sphere with the radius of symbol R. Right. It's a note, right? It's an extra note which I have discussed previously. So let's take these situations. Okay. Let's take this situation. Okay. First one. What is the first one? Inner surface. Inner surface. R is smaller than to the capital R. Right. Let's talk about that one. So it's the extra thing. So when I take the M, when R smaller than to capital R, when R inner surface of the earth, inner surface. So in the inner surface, what is the I also again I will draw in inner surface. What is the mass accumulate in the that radius? I have to take R. All right. This is capital R. Okay. Write down. Write down. Write down the topic. Where is greater than inner surface of the earth. Okay. Then write. Then write. In this case, the entire mass of the in this case, the entire mass of the earth, do not consider only the mass inside in the sphere to the reference point symbol A should be taken. Okay, let's go to that point. Okay, in this case, we have to apply that equation. What is G equals to what? GM over R square. Right? We have to apply this equation. But you have to consider what is the mass inside in this sphere, right? Not considering whole sphere, right? Let's take the mass of Earth. Capital M, right? This capital M is on the total volume. Is on total volume. That means the total mass is the capital M, right? We have to take this mass separately. So how can I find this M dash? M dash mean mass inside the sphere, radius Ibala, right? We have to take the inside the inside of mass. Okay. The total mass in the all over the volume. All over the volume in 304 pi r cube in the capital M. Capital M are including the total volume, right? We have to take the M dash first. Cube. What is the M dash? Why we are using like this? Because the gravitational field at A, G at A equals to G M dash over square. G M dash over R square, right? We have to take the gravitational field inside the Earth. Gravitational fields inside the Earth, right? We have to take the gravitational field inside the Earth. So, what is the we have to take the M as M dash. Okay. So M dash, how can I find the M dash? M dash is the to this volume, this mass. To this one, this is the mass. Like all the mathematics. M is to the this volume. To the this one, this is the mass. So this is cancelled out. So I can tell M dash equals M R cube over R cube. Okay. Right. Okay. Write down. Let's take the mass of the Earth capital M. Earth capital M. And draw this one. Draw this one. And draw the simple radius with the simple arc. Right. Draw this one. This is the gravitational field intensity inside it. Gravitational field intensity inside it. Okay. So this one is okay. So M dash is this one. This is total volume. This is the considered volume. Right. This one is the mass inside the this one. Okay. So dA equals what? dm square. I take the m square from this. M r cube over r cube into r square. Okay. Then this r square to this one cancel out. Right. So I can take GA equals to GM over R cube into R. Right. This is the inside of the gravitation field of the inside in the Earth. Okay. Write down. This is the value. Okay. Okay. Then write down. I think it's okay. Okay. Then write down. In this case, see Gm. G is the gravitational constant. M is the mass of the Earth. R is the radius of the Earth. Therefore, we know no need these are the constant, right? We cannot change the mass of the earth. We cannot change radius of the earth 6,400 kilometer. It cannot be changed. That means these are the constant. So therefore, G proportional to the R. G proportional to the R. Okay, write down capital G, comma capital M, comma capital R, comma capital R are constant, are constant, are constant. Therefore, G proportional to the R. So these are constant. Therefore, G proportional to the R. Therefore, G proportional to the R. G proportional to the R. Simple G increases. Simple G increases. Center from the center towards from the center towards the surface. It is increasing from the center towards the surface, right? When it increases, G increases, right? Okay. G M are constant, therefore, uh, G proportional to R, G increases from the center towards the surface, towards the surface, from the center towards the surface. Okay, I take the D part, right? R equals to WR. Okay, I this R equals to the capital R on the surface. Okay, so on the surface, what should I do? You know, on the surface, on the surface, G equals to what? G M O R square. We have to consider what? The total mass in the surface. To that equation, total mass over what is the radius? Capital R square. This is the this is the value of the gravitational field intensity on the what? On the earth, right? Okay, write down part 3 on the surface R equals to capital R. Okay, write down in this case, in this case, in this case, we have to consider, we have to consider the entire mass, we have to consider the entire mass of the earth, entire mass of the earth, of the earth. Therefore, GD equals to this one. We take as the G naught. It is the maximum value of the gravitational field intensity. Maximum value. Right. Write down. Then write down. This is the maximum value of the. This is the maximum value of the gravitational field intensity. Gravitational field intensity. Gravitational field intensity. Right. Sometimes we know in the earth, in near to the earth, G naught equals 10 nkg minus 1. It is 9.982. But we are considering in A level 10 nkg minus 1. The radius of the Earth equals 6,400 kilometers. Therefore, from this equation, we can take G naught equals Gm over R square, G naught R square equals to Gm. So find out the answer for Gm, substituting these values, find out the answer for Gm. Find out. Okay. Yes. So when we apply the G equals 6.6 into 10 to the power minus 11, so sometimes it is difficult. Because of that, we can apply EM as G naught R square, right? R equals 6,400 kilometer. 6,400 kilometer. So G naught R square, GM equals to what? G naught mean 10. 10 into R square means 6,400 square. So we have to apply in meter 10 to the power 3 square. So this is the answer. Right? When apply this one, what is the answer? I think you are correct now. 6,400 square 10 to the power 6 10 to the power 7. So 4.096 into 10 to the power 14. Right? I think this is the answer. We have to use the meters. Huh? Okay. In some calculations, we are using this one rather than it's better than it to when we apply the 6.67 in 10 to the power. Likewise, it's better. Right. Right now. So when you apply 6.67 into 10 to the power minus 11 and the mass of the earth, it's very difficult. So that's why we are using the GM equals to E not R square. So write down another, I think this is clear. So then simple C part. C part. C mean R greater than to capital R. Outside of the earth. Outside of the earth. Right? Write down outside of the earth. So that case, we have to consider what is the mass. We have to consider what's the mass. This is M. So we are considering these type of spheres. So it is simple R long and this is the radius is capital R. So we have to take the total mass of the earth. Total mass of the earth because the sphere containing this mass. Okay. Okay, write down. So when you apply that equation, what is equation? G equals to Gm over R square. So that equation we have to apply what is the mass, total mass. Okay. So write down in the case also, in this case also, we have to consider we have to consider the entire mass of the earth. We have to consider the entire mass of the earth. Entire mass of the earth. Entire mass of the earth. Right. Okay, write down. Draw this one again. G equals to GC equals to what? GM over R square. GM over R square. Okay. Okay. Now draw the diagram for entire situations. So draw the diagram. The gravitational field changing with the gravitational field G changing with the radius. Draw this one. Draw this one. Draw this one. The variation of the gravitational field. The variation of gravitational field with the radius. What is the shape of this one? What is the maximum gravitational field intensity? It occurs at the surface. At the surface. So we can obtain the maximum gravitational fields at the surface. It is G naught equal to Gm over R square. It is reducing, right? Gc proportional to the 1 over R square. Right? 1 over R square. That means it reducing. Right? So how can I draw the diagram? So this is increasing and then right? This is proportional to the R. When radius increases, gravitational field intensity increases. Then decreases like this. Okay? G inversely proportional to R square. Inversely proportional to R square. Right? Okay, write down. You have to memorize this shape. Okay? This is equals to y equals mx and is reducing. Right? Okay. Write down. Let's write down the problem. The shape, the spherical shape is the planet having a mass, 10 to the power 6 kilograms, 10 to the power 6 kilogram. The mass is 10 to the power 6 kilogram. And the radius 100 meter. And the radius 100 meter. Find out the gravitational field intensity at the distance number 1, 0 meter from center. Number 2, 50 meter from center. 50 meter from center. Number 3, 100 meter from center. Number 4, 200 meter from center. Okay, find out. The G is 6.67 into 10 to the power minus 11 in K, right? Newton m square kg minus 2. Okay, find out. We have to find out the what are the gravitational field in intensity. Number 1, this one. Number 2, this one. This is 50 meter. Number 3, this one. Number 4, this one. Okay, find out. Quickly find out the values. Quickly find out the values. Give, give me the answer. At the center, G equals to what? Gm over r square. No? There is no including the mass. There is no mass. Therefore, G equals 0. Number 2. When at the 50 meter, we have to take the total mass in the that 50 meter radius. So to consider in total volume, that means 304, 5, 50 cube equals to the mass 10 to the power 6. So when considering R equals 50, no, total volume is 100, no, 100. 304, 5, 50 cube. We want to take that mass. Okay. Okay. How can I take that mass? M equals to what? M dash equals to 10 to the power 6 kilogram into the 435,000 cube. Therefore, 3, 4, 5, 50 cube. Okay. Mass 50 cube over cube of this one, m dash. Okay. Then I can take the value as what? 50 cube, no? 10 to the power 6 into 50 cube. It is also 10 to the power 6. Cancel out 50 cube. The mass of that one is 50 cube. Cube of the 50. So I can take this space. So number 2, G equals to what? G equals to G m dash over R square mean 50 square. Okay. That means 6.67 into 10 to the power minus 11 into m dash mean cube of 50 square. So I can cancel out 66.7 into 5. 66.7 into 5. 6. That means 5 into 10 to the power minus 11. 3.335 into 10 to the power minus 9. Okay. Okay. Yes, your answer is correct. Then number 3. When considering the total mass, number 3. When considering the 100 meters from the center, the G is m over R square. So G means 6.67 into 10 to the power minus 11 into m mean 10 to the power 6 over R square mean 100 square. 6.67 into 10 to the power minus 11, 10 to the power 6 into 10 to the power square of this one mean 10 to the power 2, and this one is 2 10 to the power 4. So I can cancel out this one and 6.67 into 10 to the power minus 9. Okay. This answer. Number 4. What is the 200 meter away from the center? That means G equals to Gm over R square. Right? 6.67 into 7 into 10 to the power minus 11. Mass mean 10 to the power 6. Radius mean total radius 200 square. Yes, your answer is I think correct. 6.67 over 4 into 10 to the power minus 6, 10 to the power minus 5 over 10 to the power 2 means 10 to the power 2 to power, that means 4, 10 to the power 4. Yes, I think this is the answer. 1.26 mean 6, that mean again 2, 27 mean the 6, 10 to the power minus 9. I think this is the answer. Yes, the answer is correct. So the units are in kg minus 1, in kg minus 1, in kg minus 1. Okay, good. Right. I think it's clear. Then write down another topic. Another topic. Circular motion. Circular motion. Circular motion of simple M. Circular motion of simple M around the mass capital M. Okay, write down. So the circular motion. So the moon having a circular path on the over the earth, right? And also earth having a circular way from over the sun, right? This mass simple M over capital M, right? Having a horizontal circular motion. So what is the, if if they having a circular motion, what is the centripetal force? Centripetal force. What is the centripetal force? The centripetal force is given by the gravitational force. By the gravitational force. Okay. Then it's moving with v velocity. I draw the good. Okay. I think this one is better than M, capital M, having the radius simple r, and it moving with v velocity, right? Okay. Then there is a force F and F. Okay. Moving around the earth. Oh, yes. Okay. Write down the centripetal force is gravitational force. Okay, write down the motion of planets around the sun. The motion of planets around the sun, and the motion of the moon around the earth, and the motion of the motion of the moon around the earth, motion of the satellite around the earth, motion of the satellite around the earth can be considered as example to the circular motion around the masses. The centripetal force required to a circular motion of a simple m is provided by the gravitational force. Provided by the gravitational force. Okay. The centripetal force required provided by the gravitational force. Okay. Write down this one. Draw this one. Draw this one. Draw this one. how we can get the value for the velocity? Value for the velocity, right? This is the circular motion. I can apply F equals ma to center, right? F equals to F equals what? F equals GMM over R square. That means the gravitational force. Gravitational force. Okay? Gravitational force. Therefore, the gravitational force. So F equals ma. F equals to what? GMM over R square. Equals to what? Ma. Mass. A means the radial acceleration. Radial acceleration. That means v square R. So I can cancel out this one. Then this v square equals to gm over r. V equals to what? Gm over r. Okay. I think you are clear now. Okay. Write down velocity of the simple m around the capital M. Around the capital M. Okay. Write down. In this formula, capital G, capital M, capital G, capital M are constant. In this formula, capital G, capital M are constant. If the radius got increased, velocity get or speed get reduced. But the mass of the object is not affecting to the speed. But the mass of the object not affecting to the speed. Affecting to the speed. So then write down the gravitational field intensity. The gravitational field intensity of the orbit is considered as symbol G. When applying F equals ma to the center, right? F equals ma. So if the gravitational field intensity is simple G at this point, therefore force equals F equals mg. Right? I draw the cross section, some section. So it's moving this velocity, the gravitational field intensity is G. So the force is F equals mg. So I can apply now F equals mg. mg equals m a. A mean v square over r, the radius from the center. So in this case, I can cancel out v square equals to g over r. V square equals to gr. So v equals to root of gr. Okay. This is the value. Right? Simple G is the gravitational field intensity at point r equals to radius of the orbit. Radius of the orbit. Right. Okay, write down. Okay. Then write down the subtopic Kepler equation. What is that? Kepler equation. Kepler's equation. So you know who is the Kepler, right? Kepler, who had found the telescope. Yeah? Right. So it is the equation is the showing, right? Showing that r cube proportional to the t square. Showing that r cube proportional to the t square. Okay. Write down. Write down the relationship between the radius and the period of time, radius and the period of time, radius and the period of time can be established by applying F equals ma to the center. By applying F equals ma to the center. So I draw again. So simple m mass is moving in the circular path with v velocity, right? So the radius, it is simple r. Okay. And also it having omega. That means angular velocity. I take as the omega. Okay. So I apply F equals ma to center. Apply F equals ma to center. So this is what is the force? Force equals to what? F equals gmm over r square. Gmm over r square equals to what? M. In this case, I take v, not v, omega. Omega square. How can I apply omega square? You know what is the radial acceleration? V omega v square r omega square. Right? So I can apply this one. M to M cancel out. Then I can tell gm over r square is omega r I hitting downwards. So r cube. Okay. So you know how can I build a relationship between the omega and the t? Omega and the t, period of rotation. Omega and the t, what is the relationship between omega and t? In circular motion, we know, but omega equals 2 pi over t. Circular motion, it is not the equation. Omega equals to theta over t. Time of the rotation is t. Theta equals 2 pi. That's why we are using this equation. So omega equals 2 pi over t. Then we can apply gm over r cube equals 2 pi over t. Omega square, no? Omega square. Right? Therefore, I can get the relationship Gm over R cube equals to 4 phi square over T square. T square equals 4 phi square over Gm over R cube. Right? See, phi, G, M are constant. Therefore, T square proportional to R cube. This is the Kepler's equation. Okay. Okay. Plus relationship. Right. Write down. Write down. Give me a one. Okay. Right. Then write down. Write down the topic. Geostationary satellites. Write down the topic. Geostationary satellites. We are discussing satellites. Geostationary. What are the geostationary satellites? Some satellites are located above the countries or geostationary. Right. Some satellites are located above the countries. It is stationary on that country. Why? Sometimes the satellite that signal sometimes in the earth. So there are if there is a Sri Lanka, in the above from the Sri Lanka there is a satellite. Why? Some companies are producing their satellites because to satellite telecommunication. So some dial-up TV and other things. It is above the earth, above the Sri Lanka. Likewise, there are so many satellites. It is stationary on the uh, upper area of the some countries. So they are calling this geostationary satellite. Okay, write down. Geostationary satellite having a geostationary satellite having a geostationary satellite having a 24-hour time period. 24 hours 24 hours time period, and it always locate at the same point, and it always locate at the same point above the earth. Above the earth. So the T is 24 hour, right? Therefore, it's locate on the earth above the one point. It's rotating around the earth. They are geostationary satellite. Okay. Then okay, it's a small thing we have to know. So write down another topic. Gravitational potential. It's a main topic. Gravitational Gravitational potential. Write down gravitational potential. What is the mean by the potential? That means the capability doing work like that, no? Therefore, this also like the same similar meaning. The capability that the mass having a doing a work like that. Okay. Write down. Since any mass placed at a certain point, since any mass placed at a certain point in a gravitational field, in a gravitational field, in a gravitational field is subjected to, is subjected to, is subjected to a gravitational force, a gravitational force subject to a gravitational force, a certain amount of work, a certain amount of work is done by the field, is done by the field in bringing this mass, in bringing this mass from outside the field, from outside the field, from outside the field, in brackets infinity, from outside the field, outside the field, in the point, this point, to this point. When we when symbol M mass placed to this location, the work done is the gravitational potential, right? From the infinity, right? So, right, while this work is accumulated, while this work is accumulated, as the potential energy, as the potential energy, as the potential energy, and the work done per unit mass, and the work done per unit mass, in begin it to this point, in begin it to this point, is referred as, is referred to as the gravitational potential, the gravitational potential at the point, gravitational potential at the point. Okay. When we place the symbol ms to this point from the infinity, that's called the gravitational potential. Gravitational potential. Okay. Right. That's the work done by us. So when we take some mass from the infinite finite to this one, do we have to do a work? So uh, if you are jumping from the uh, highest place, so you have to work done. You should have to do some work done to go down. No, because gravitation mean it is attraction. So if you are climbing to a mountain and if you jump to the down, so you normally come into the down. So that means gravitation. So when we get in some mass from infinity, infinite distance to this point, do we have to do some work done? No. Why? it's always attracting this mass. So the work done is negative, right? We do not want to do any work done. Any work done. Okay. Okay. Write down. Okay. Write down. Gravitational potential at a point in gravitational potential at a point in the gravitational field. The gravitational field due to an isolated mass due to an isolated mass considering p point in the gravitational field isolated mass, right? Sorry, uh write down it as the topic. Yes, okay, write down it as the topic, don't need to write this one. Write down topic gravitational potential at a point. This one I will write separate. Gravitational potential at a point in the gravitational field, in the gravitational field, in the gravitational field due to a isolated mass, due to a isolated mass, due to a isolated mass. So in previous case, you if you can draw this one, we bring in simple m to this case. There is a work done is equals to potential, gravitational potential. Okay. Then write down the topic gravitational potential at a point in gravitational field, in gravitational field due to an isolated mass, due to an isolated mass. Okay. Okay. Then write consider a p point, consider a p point in gravitational field, in gravitational field due to mass capital M, due to mass capital M, and it's situated at a distance, and it's situated at a distance, situated at a distance symbol r from the mass, symbol r from the mass, symbol r from the mass. Okay, draw this one. This is a point, p point. We need to find the gravitational potential at the p point. Okay, draw this one. What is the potential mean? Potential mean when we are getting some simple m mass to this point from the infinity, infinity, right? Unit mass from the infinite to the that point. There is no work done. Work done. There we do not do the work done. Work done by a gravitational field because the masses are attracted to the gravitation, right? Therefore, therefore, write down. It is possible. It is possible. It is possible to derive mathematically that the work done, to derive mathematically that the work done when begin mass, unit mass, when begin unit mass from infinite to the P point, from infinite to the P point, work done equals minus Gm over R. This is derived using mathematically. Using integration, we can derive this equation, right? Using integration, right? If you are doing a mathematics, you can derive that one. If you are doing a bio, you cannot do, right? How can we get? We have to integrate infinite to the this one, R distance. How can it take? You know, there is a limitation in the integration, right? Using limitation in the integration, we can use take the work done. Okay. Okay. Write down. It's not a big deal, but so to the bio people, they cannot do no. Okay. Then write down work done is the minus Gm over R. Therefore, 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 the gravitational potential at P point, the gravitational potential at P point, capital V, its gravitational potential mean capital V equals to minus Gm over R. Minus Gm over R. Okay, write down. This getting by the integration. Huh? This is getting by the integration. Why there is minus sign? But I told when we enter to the mass from infinite to the center, it is always attracting. Because of that, we need to do the another work done, no? Because the work done also doing by the gravitational field. It is a free of charge. Therefore, there is a minus sign. There is a minus sign. Okay? Okay, write down. The potential is the අපි ඒ කියන්නේ mass එකක් මෙතෙන්ට place කරන්න කොච්චර work done එකක් කරන්න ඕනද work done එක කියලා කියන්නේ මේ mass එක attract කරන්න අපි mass එකක් ගේනකොට මෙයා attract කරනවා. එතකොට mass එක attract කරන හින්දා මෙයාගේ දිහාවට යනවා mass එක. තේරෙනවද? එතකොට mass එක attraction එක නෙවෙයි. right? ඒකයි මේකේ sign එක minus වෙන්නේ. Because of that the minus sign is indicated. Right? Because of that the minus sign is indicated. හරි? Right, ගියාගන්න the negative sign indicates that the relevant work done by relevant work done by is done by the field and not against the field, not against to the field. Okay, not against to the field. Also, since work is a scalar, therefore gravitational potential also a scalar. Therefore, gravitational potential is also a scalar quantity. Right. Then write units of V is Joule kg minus 1. Joule kg minus 1. Right. How can we represent the gravitational potential in the graph with radius V? It is inversely proportional to the radius. Inversely proportional to the radius, but the values are minus. Therefore, we can illustrate using this graph Joule kg minus 1 meters. Okay. Okay, write down. The following graph illustrate. The following graph illustrate the variation of variation of gravitational potential with the distance. Gravitational potential with the distance to the mass. Distance to the mass. Right. Draw this one. Draw this one. Okay. Okay. Right. It was so after that Leander. The maximum potential may occur, may occur, may occur at infinity. At infinity, it is a zero. It is a zero. Why? The others having a maximum potential at infinity is zero. Others are having a minus value. When increasing the minus value, the value is smaller. The larger value is zero, right? That's how can that's the way we are using this one, right? When the radius into the when we come to this end, the value is getting the reduced. At the infinity, value is zero. That means increased, right? Likewise, you are reading. Yes. Then right, the difference between potential, the difference between potential, the difference between potential of 2 points are known as then right, the difference between the potential of 2 points are known as the potential difference, the potential difference of points. If we the in the potential difference, I I consider A and B, A and B, B and A. So when the mass is placed this one to this one, so the AB, the potential difference of AB equals to VA minus VB. Right? This is called the potential difference of A relative to B. Right? Okay. Write down this one. Potential difference of A relative to B. Okay. This is the potential difference. So potential is the minus value. Minus value, if we getting closer to that, R is reduced. This minus sign is increase. හරි ඍණ ගානක් තිබ්බොත් ඒක ඍණ ගාන වැඩි වෙන එක බිඳුවට වඩා ඍණ ගාන වැඩි වෙන්නේ නැහනේ. right? බිඳුව තමයි වැඩිම වැලියු එක. minus ඍණ ගාන ඒ කියන්නේ minus වැලියු එක තමයි අඩුම වැලියු එක. right? minus ගොඩාක් තිබ්බට වැඩක් නැහැ. 0 කියන එක න වැඩි ඊට වඩා. infinite වල 0 කියන එකනේ තියෙන්නේ. එහෙනම් 0 එක වැඩි ඔක්කොටම වඩා. right? that's why right. then right potential difference between potential difference between 2 points is defined as 2 point is defined as 2 point is defined as the work done 2 point is defined as the work done in a moving unit mass. Work done when a moving a unit mass when a moving a unit mass from one point to another. From one point to another. I will take as this as example. When I place simple m mass from this point to this, right? So I know, let's take as the radius. This is R2 and this is R1. Okay. The potential at A point minus Gm over R2. Potential at B point minus Gm over R1. Minus Gm over R1. Right? So, හරි. දැන් කියන්න බලන්න මෙයාගේ වැඩිම නෙගටිව් වැලියු එක තියෙන්නේ කාටද? නැත්නම් වැඩිම වැලියු එක කාටද තියෙන්නේ? When R increases, the value decreases. Therefore, VA is the smallest negative value. Right? ඒ කියන්නේ මෙයාගේ මේ රේඩියස් එක වැඩි වෙනකොට මෙයා නේද අඩුම නෙගටිව් වැලියු එක තියෙන්නේ. එහෙනම් VA කියලා කියන්නේ අඩුම නෙගටිව් වැලියු එක. ඒ කියන්නේ VA කියන එක නා higher than to the VB. ඇයි එහෙම කියන්නේ? නෙගටිව් වැලියු එක වැඩිම R1 පොඩි හින්දා නෙගටිව් වැලියු එක වැඩි. වැඩි කියලා කියන්නේ නෙගටිව් වැලියු එක වැඩි කියලා කියන්නේ ඒක අඩුයි. right? නෙගටිව් වැලියු එකනේ වැඩි. එහෙනම් ඒක අඩුයි. so VA කියන එක නා higher than to the VB. therefore VAB equals to this is the work done. අපි මේ VA කියලා කියන එක කියන්නේ කොහොමද? A කියන පොයින්ට් එකට යුනිට් මෑස් එකක් ඉන්ෆයිනයිට්ලි ඉඳලා ගේන්න කරන්න ඕනේ වර්ක් ඩන් එක. B කියලා කියන්නේ මොකද්ද? when we taking the unit mass to the B point, the work done is this one. Okay? Therefore, VAB equals to VA minus VB. Right? That means minus GM over R2 minus GM over R1. Okay. Therefore, GM over R1 minus GM over R2. VAB. Right? This is the value. Okay. Write down this one. This is the potential difference. This is the potential difference. Let's do some exercises for the potential. Right? To take an idea, let's do an example for the potential. Okay. 2 kilogram Okay. Write down the problem. Write down the problem. Find the potential at A point. Find the potential at A point. Okay. Find the potential at A point. How can I find the potential at A point? Okay. Potential is the what? Is the scalar. Scalar mean the only we have to take the summation. Only we have to take the summation. Right? Therefore, how can I verify first verify and if you can find out. Okay. To find out the potential at A point, we have to take the normal values. Okay. First of all, again, come values can A වල ඉඳලා මෙන්න මේ 2 kilogram ට තියෙනවා 5 centimeter distance එක. Right? So we have to take the first one 2 kilogram. Therefore, minus dm over r. Right? Get the summation of that one. VA equals minus G, M means 2 kilogram over R means 5 centimeter distance. Okay. Plus the minus value of the this 2 kilogram. This 2 kilogram. Therefore, minus G 2 over 5. Centimeter means 10 to the power minus 2. 10 to the power minus 2. Minus 2 G 2 over 5 into 10 to the power minus 2. Therefore, this is 4 minus 400 G over 5. That is 80 minus 80 G minus 80 into 6.67 into 10 to the power minus 11. This is the value. Okay. What is the value? 5.336 into 10 to the power minus 9. Right? Joule kg minus 1. Okay. Okay. Let's do another problem also. So example, I will give a problem. Only the case is you have to add the potentials. No need to find the vector summation or likewise. We do not have to take that one. We only have to take the summation of the uh, potentials. Potentials. Okay. Okay, clear. I think you are clear now. So do another problem. Right. Do this one. Find the gravitational find the gravitational potential of 4 points. Right. Find out. Find out. These are the masses. Give me an answer. Right. To calculate that one, so we have to take the value separately. Value separately. How can I take the value separately? V equal VO. VO equals to what? Uh, I have to take value separately. So what is the distance from the O? That is a problem. So how can I find the what is the distance from the O mean? So this is 2 meter, 2 meter, 2 meter. Therefore, 2 √2 meter. See, 2 meter, 2 meter, 2 √2 meter. That means this is √2 meter. I can divide them. This is √2 meter. √2 meter. So that's the case. Therefore, √2 meter, √2 meter. Okay. So find out this one. Minus Gm over R. Minus Gm over R. So how can I get that one? Minus Gm over R. Summation of that one. Gm first one 2. R mean √2. So this is first one plus minus G3 over √2. This is the second one plus minus G2 √2 plus minus G1 over √2. Therefore, I can get the summation minus G √2. That means 2 plus 3 plus 2 plus 1. Therefore, 5, 8, 8, no? 8. 8 minus 8G over √2. Is that okay? Yes. 8 means 4 to 3 into G. So I can divide it. √2 means √2 into √2. That means 4 √2 into G. Minus 4 √2 into 6.67 into 10 to the power minus 11. This is the value. So I think your value is correct. Yes. Yeah, to that value. Yes, your value is correct. 3.77 into 10 to the power minus 12 minus 3.77 into 10 to the power minus 10 joule kg minus 1. Okay. Write down the second problem. First one is to find the gravitational potential. Second one, find the gravitational intensity. Gravitational intensity at O point. At O point. Gravitational intensity at O point. Okay. Find out. Find out. Gravitational intensity means the vector summation. You need to get the vector summation. So find out find out that. Right. So to get that one, we have to take the vector summation. I had told, so I take the shortcut method. So I take as the gravitational field intensity at O point from 1 kilogram of mass. O point from 1 kilogram of mass at root 2 meter distance. Okay, root 2 meter distance. So what is the I take distance is simple g. So I can take this one is the g, and also this one is the 2g. This one is the 3g. This one is the 2g. So when I take this one, so I can also take the value also, no? G equals to Gm over R square. G means 6.67. I will do it. G M equals to 2. 2 over R square mean root 2 square. Okay. That means 2G over root 2 mean 2. G equals to G. Right. That means 6.67 into 10 to the power minus 11. N kg minus 1. Okay. I think it's okay. So when I take the O point, it is 2G, 2G. Therefore, G, 2G. Right? Therefore, G. Right? It's at 90 degree. So I again say G, 2G, 2G, 2G. So the G1, G in this direction. So the G in this direction. So there is two G's perpendicular to each other. So that's why. So what is the value? Therefore, resultant value is this is 45, this is 45, 2G plus 45. 2G plus 45 means 1 over root 2. Therefore, 2 is root 2 G. GR root 2 G. G means 6.67 into 10 to the power minus 11. N kg minus 1. That means this one the answer. So let's take 9.433 9.433 into 10 to the power minus 11 in kg minus 1. Am I correct? Point. Wait, I think. Sorry, there is a small mistake. This is the 1 kilogram. So this is G over 2, no? G over 2. Over 2 mean 3.335 into 10 to the power minus 11. Okay. Sorry. So when we substitute this one, we have to divide it by 2. So 4.7 6 6 into 10 to the power minus 11 nkg minus 1. 4.76. Yes. Good. I think this is the answer. Your answer is correct.